Yeah, buddy. Let's do some proofs here. Okay, so what do we know, right? Coming in geometry, we know algebra. Hopefully, if you don't, you should learn that. I mean, that's arguably the most important math class you'll take in your whole life. I mean, anyways, I digress. Learn algebra for sure, absolutely. But we're going to use that on the assumption that you all come in with at least a moderately strong grasp of algebra. And we're going to use that as our first proofs. Really, we're just going to be solving an equation and justifying each step, saying I could get from step A to step B because this valid reason. And we're only going to have about 7 or 8 valid reasons, okay? So our valid reasons are properties of equality. I add one that the book doesn't, and I don't even give it a specific name. I give you a couple of choices, okay? So there are 1, 2, 3, this is 4, 5, 6, 7, 8, 9, and I add 10. Woo, I can't count. I told you, right? 8, and there were actually 10, okay? That's how many properties of equality there are. These are valid steps you can take in a proof, okay? Reflexive property of equality means that any number, again, algebra is only numbers or placeholders for numbers, is equal to itself, okay? We're not going to use that one in proofs, okay? However, when we get to congruence, when we get to like proving things about triangles, we'll use reflexive property all the time. But in terms of equality, we're not going to use it. Okay, symmetric property, we're not going to use that either. It just means if A equals B, then B equals A. We can reverse the direction of the equal sign. Again, not very useful. We're not going to use that. We're not even going to use that with congruence. So you can just ignore that one. Okay, transitive property of equality. So these first 3, we're going to develop a lot because these are going to be the only properties we have when we talk about congruence. And in fact, a lot of relationships as you move forward in mathematics, these are the 3 fundamental ones that that make it, I think it's called an isometry. But these are the 3 fundamental properties that we develop and use, which really just says anything is the same as itself. And if we have 2 objects that are the same as a third, then they're the same as each other. And that's really all we know. We don't have plus and minus and square roots. That's only with numbers. And so these properties are more universal. However, we're not really going to use them with equality. We're going to use them when we get to congruence. Absolutely. Okay, but for equality, starting at this one, we have the addition and subtraction property, which simply says if we start with A equals B, so if we start with an equation, 2 things that are equal, I can add the same thing to both sides. I could add C to both sides, and I don't break the equation. The 2 sides are still equal. Same thing, I could subtract from both sides. Now really, there's no such thing as subtraction. You're just adding a negative. So really, there is only the additive property of equality. There's no such thing as the subtraction property of equality because there's no such thing as subtraction. We're really just adding the opposite. But you could call it both. It's totally okay, additive or subtraction, okay? The multiplication and division is the exact analogous one, saying if we start with something that's equal, right? It could be like 2x minus 1 equals 5. Then I'm allowed to, the last one said I could add 1 to both sides, and they're still equal. And now what that does is that gives us 2x equals 6. This next one says I could multiply or divide the same thing to both sides, and it doesn't break the equation. Now, it does say you can't divide by 0, right? That's like the one golden rule in mathematics. That just explodes the universe. So here, we could divide both sides by the same number, 2, and the 2 sides are still equal, right? Because both sides were 6. Now, the left says 2x, but it's equal to 6. So we divide both sides by 2, and now we have x equals 3. So we can use valid steps to get to that solution. The last ones are substitution property. That's the real reason we don't need the transitive property, is because we have a more global general rule. Substitution simply says, if we have 2 things that are equal, you could replace either one with the other, right? So if I know A is equal to B and I have B plus 1 equals 7, I could just go, actually, I'm going to erase that and I'm going to put in an A there instead because they're the exact same, right? They are equal. In algebra, that's all of the equivalents that we have. Those 2 are the exact same, right? So that's substitution. And then distributive property is really cool. It's just saying if I'm multiplying a group of terms, right? If I'm multiplying A times the group B plus C, I can distribute that in, and I get that's A times the first plus a times the second. And we'll use that a lot, okay? We could also use it in reverse, like we could factor out. We're not going to do many problems like that, but you could also do the reverse of that too, because it's an equal sign. It's not a conditional arrow. It's just saying those two things are equal. So whether you're saying this equals that or that left equals right, it's an equality. It's a biconditional. There's no if this one direction. It's equal, so both sides are equal to the other side. The last one too is often we'll get something like 2 plus 3, and we just want a next step write that that's 5. Right? There's no necessarily property of equality, but I would say there's at least 3 good ways to write that. One, just say arithmetic, right? I just did a calculator, beep, boop, bop, beep, and the number is 5. Or you could say I simplified it. Again, we're not talking about like changing the equation, like 4 through 9. Instead, we're just saying I'm cleaning up numbers, okay? What about in this next one? What's 2 times a half? Oh, that's just 1. Those like cancel out with multiplication division, right? So that's 1x. Again, that's just simplifying or arithmetic. Another way to write it is you could literally say 2 plus 3 equals 5 is the very definition of addition, right? That's a kind of cool way to write it. So any of those 3, definition of the, math operation used, or simplification or simplify, or arithmetic. Any of those 3 would be a good step, because a lot of times in the book, it'll do something like, it'll say, I don't know, like let's say it was 5 times x plus 3. So it'll say, oh, distributive property gets you 5x plus 5 times 3. And then a separate step would be 5x plus 15. And that would be I simplified. That's how I did that step. Now, I will let you totally just go from here to here, saying that was the distributive property. You don't need a separate in the middle to show 5 times 3. But depending on the problem on the book, be aware of that, because that will come up in the textbook. And so you need to know you could do that in 1 or 2 steps. Okay, so a good proof, make sure you have at least, right, you state the thing you're going to prove, right? You state the given. So this one is kind of optional if there is some like name or something. So this might be you just go, oh, this is number 35 in the book or something. But you need to say what's given. So you go given, and you'd write information. And then you need to state what is to be proved right below. So you say, I was given that information, and I want to prove this information. And then, if possible, draw a diagram. So then you would have a picture over here like, oh, look at these 2 lines intersecting, and here's the angle we're talking about, and so on and so forth. And then you develop a system of deductive reasoning. So first, we're going to do 2-column proofs. So it's going to look like this. We're going to say a statement, and then we're going to justify it with a reason, right? So we're going to say, okay, 1, we were, here, and I can know that because that was given to us. And then we just, develop the proof down below, and that's what we're going to practice in this video. But I just wanted to really highlight that a good proof, you should always state the given, state what you're going to prove, and include a diagram, and then you develop the proof. But beforehand, you need to know where you're starting and where you're going, and have all of the relevant information, aka the diagram, available to people. Okay, so let's do some proofs. So I chose one problem, and I'm going to do it in 2 different ways, just to show you that there's no one right answer to a proof. Proving something is really an art form, and creating an elegant proof, it's beautiful to look at. Like the parts, they've done studies where the parts of the brain of mathematicians, when they see an elegant proof, the same parts light up as other people when they see art or listen to opera or something. It's the recognition of beauty in an elegant solution. And so here, we'll set this up, okay? So if this, then this. So really, and I'm going to do this nice and slow, so this video might get long, not because this is difficult, but because I want to give you lots of examples, okay? But hey, it is difficult. This is the first time for a lot of people. There's no reason to, take that away from people. Okay, so given the if part, so we have this, and we want to prove that x equals 2. Okay, we're going to start with 2-column proof. So we have statements, and we have reasons. And I'm going to number them all, because otherwise it's like which one goes with which. That one with that one, and that one and that one. And they start not aligning. So I'm always going to use numbers. Okay, so we know that 3 times x minus 5 over 3 equals 1. We can know that because that was given to us. Okay, so 2, we could distribute that in. So we get 3 times x minus. Now again, I'm going to do this in 2 steps the first time, and then after that I'll do it in 1 step. So I'm going to write this as 3 times 5/3 equals 1. We did that because of the distributive property of equality. So you need to write property of equality, but you can abbreviate it like that. Okay, so 3, all I'm going to do is simplify that. So 3 times 5/3 is 5. And I'm just going to call that arithmetic. Okay, you could have called that simplify. You could have called that the definition of multiplication. I'm okay with any of those. Okay, so 4. Then I'm going to show in another color what I'm going to do. I'm adding 5 to both sides. That's what I'm doing. That's the in-between. You don't write that. Okay, what you're going to write instead is the end result. So after doing that, I got 3x equals 6. And what let me get there? Now remember, the reasoning here, me saying the distributive property, that's saying I know how I got from this step to this step. I arrived. I'm not saying, a common mistake is people write distributive property up here, predicting the future, saying, I'm about to use the distributive property. That's not what a proof does, okay? A proof says, how did you get to statement 2? What reason, what valid logic let you get to step 2? And you say, I can justify step 2 with the distributive property of equality. Anybody could look that property up and go, I see what you did there. That's totally valid. I can't argue with that. That's infallible right there. That's a beautiful, elegant step. You proved it. You justified it. Well done. Okay, same thing down here. I'm saying, how did I get from here to here? I added 5 to both sides. So what let me do that? Well, what let me do that is the additive property of equality. So I did a simplification there. I do circles around my symbols so they're really clear. But you would say additive or addition property of equality. That's what let you add. And then lastly, you could do this. Let's do it in 2 steps. Again, in the future, I'll do it in 1. But I could show, let's do it in 1. What am I talking about? We're not going to be doing this in 2 steps. So you divide both sides by 3. Again, I'm just showing my work. You don't need to do that. But in the end, we get x equals 2. And what let me get there? Well, I divided by 3. And I know I can do that by the multiplication property of equality. Okay, so let's do that same proof in a different way now, okay? So again, I'm not going to restate the given and the proof because I just did it right there. So same given and proof. Okay, so we have the statement. Oh, wait, why am I drawing an arrow? I'm on a freaking digital device here. Let's just actually do that. Let's just circle this, copy, and freaking magic. What's up? Oh, I will write it. No cutting corners. You young hooligans with pencil and paper, you go ahead and write it because that's what your teacher did. Okay, so anyway, statement and reason or justification. There's lots of things you could title there. But instead, I'm going to go a different direction with this. Can you guys see what I might do in this first step that's different? Okay, so on the first step, I'm actually, this time instead of distributing, I'm just going to go ahead and divide by 3 on both sides, okay? All right, so now where does that take us? So we now get x minus 5/3 equals 1 divided by 3, 1/3. Oh, I didn't write the reason. We know that first thing is true because it was given. And we know the second thing is true because of the division property of equality. Okay, now the third thing, what are we going to do with the third thing? We are going to add 5/3 to both sides, right? And this time I will kind of break it up into 2 steps. I'll say, okay, so that means x equals, and I'll first write this is 6/3. And what let us do that? That was the additive property of equality. And then step 4 is x equals 2. And how do we get there? That I went ahead and just simplified the fraction. So you see, you could shorten that into steps, but just for clarity, again, a proof is really about just communicating a clear flow of logic. And so in that case, I thought it was more beneficial to show 6/3 and then simplify rather than going directly to 2. I think that would have maybe confused people. Go, how'd you get from 1/3 to 2? Did you multiply, add, subtract? So I think writing in another color, the step I'm doing in between, and then going to the 6/3 first, I thought that was a more clear version of the proof. But you notice these two proofs are totally different. So it's an art form of creating and communicating clearly, like writing an essay, right? Every kid's essay is going to be different, and some are going to be much more articulate, well organized, well structured than others, and that's really what we're developing here. Okay, so let's do some more. So write a statement that illustrates the substitution property of equality. Okay, so for one, I could say something like A equals B, and then I could have something over here that's 2A plus B equals 7, right? And so then what I do is I go, oh, wait a second, since A and B are the same, I'm just going to go ahead and put an A there instead of B. And I can use colors because, I mean, you can use colors too. You've colored pencils or pens. So that's the idea, is you are taking this A equals B and you are using it right here to swap A in for B. And now that lets us solve it, right? So now we can go 3A equals 7, A equals 7/3. And then we could even go, oh, well, then that also means, since A is equal to B, that also means B is 7/3. So that was a useful time we would use it, right? So 2, describe the parts of a 2-column proof. Okay, so first we write the given. Okay, and I'm not even talking about in the proof, where I'm talking about above. Okay, we write the to prove. Okay, we draw a diagram. Again, this is optional. Some don't require a diagram, but I'd say 90% of proofs do. Okay, then we set up the 2-column, I don't know, like structure or drawing or table, whatever you want to call it. And then there are the statements on the left. And I'd even say they're numbered. And then we have the same thing, but reasons on the right, ... and those are also numbered, okay? What about number 3? State the parts of a conditional that is related to the given of a proof. And what is the proof? Well, that actually came up, right up here. So if this is true, then this is true. So remember that if part is called the hypothesis, and then the then part is called the conclusion. So what we did, whoa, that's not how you spell conclusion. So what we did is we said the if part is the given, and then we're saying the conclusion is this. So what we're trying to do is we're trying to prove a conditional statement that may have a big gap in between, right? It's saying, can you get from A, woo, all the way to W? And you're saying, okay, well, we're given A is true, and then we're going to just march along. All these is like, well, A leads to B, and oh, also B leads to C, and oh, I just found that C leads to D, and then on the side, you're like, oh, over here, E leads to T. That's a nice little shortcut. And you find all these conditionals that you chain together to get to the end. But the result is the if statement is the given, and we're trying to get to the then, okay? All right, good stuff, you guys. All right, so state the property that justifies each. So we start with 2x equals 5, and we get to x equals that. So it looks to me like they divided both sides by 2. So this would be the division property of equality. Okay, the next one, you start with x divided by 2, and then they get to x. So yeah, it looks like they multiplied both sides by 2. So that will be the multiplicative property of equality. Okay, the next one, if x equals 5 and b equals 5, so x equals 5 and b equals 5, then x equals b. So here's a great problem to talk about, okay? There are absolutely two valid solutions here. So one is substitution, right? If x equals 5, we can just replace this 5 with an x, right? Or if b equals 5, we can replace this with a b. So absolutely, this is the substitution. Notice I didn't just say sub, because that would be ambiguous. It could be the subtraction property. So I'm saying substitution property of equality. But this is actually that one thing that I said we're not going to use that often. So transitive property, if A is equal to B and B is equal to C, we can get rid of that middleman and just say A is equal to C. So really, it's like, here's all substitution. Here's the specific case of the transitive property. So for equality, since we have substitution, we don't need this more specific case. We can just say substitution for every transitive, right? So we'll only use substitution. However, notice that transitive property is saying is if A is equal to B and C is equal to B, if they're both equal to B, well, then they're equal to each other. That's actually the exact scenario right? Like this case that we did here, this is not transitive property. I just replaced b in the middle of an equation with an a. That's only substitution. However, if I had said a equals 7 and 7 equals b, then linking a equal to b, you could still say substitution, but that is the exact case of transitive when you get rid of that middleman when they're both equal the same thing. So this is also the transitive property of equality, so you can say either one. This would be the more specific name, the most accurate, the most precise, but substitution's 100% valid. It's like me saying, like, name this shape, and you saying, well, it's a square, or calling it a quadrilateral. Both are valid, but the square is more precise or more accurate, so I would call that a square, but quadrilateral is totally correct. Okay, so let's look at the next one. So if xy minus ab equals wz minus ab, then, and so what they did is they got rid of these to just state xy equals wz. How do you get rid of those? Well, you add ab. Remember, two capital letters with no symbol over it, that's the length between 2 points. That's just a number. So this is just like saying a minus c equals b minus c. How did I get then to a equals b? Well, I just added the variable c, right? Here we're adding the variable length ab to cancel those out. So that's the additive property of equality. Good questions. Okay, so let's do some proofs now. So solve that, list the property that just says each have. So it doesn't say make a proof or write a proof, but really it's asking us to create a proof here. So let's do a proof. Okay, so we are given x over 2 plus 4x minus 7 equals 11. We want to prove, I don't know, x equals some number. We don't have that yet. Okay, so let's set this up. We have, how much room do I have? Whoa, I did not give myself a lot of room. So I'm going to go ahead and just delete this given in proof because I need more space. You should absolutely write it. Okay, so let's do this. So step 1, we know x over 2 plus 4x minus 7 equals 11. And we knew that because that was given. Step 2, what should we do? Let's add 7 to both sides just to get rid of that first, okay? So we can write this is x over 2 plus 4x equals 18. We knew that because that was the additive property of equality. Now here's where you could start being like, okay, well, how do you just, now this is an art form, right? So maybe I use a distribution property to say this is x times 1/2 plus 4, right? Sure, that's distributive property, right? You distribute the x in, we get here. You undistribute, we get here. That's one way. Another way is you could just add those together and just say, well, that's just 4.5 or 9/2 of x equals 18, right? So that would be the most direct. What let you do that? You could call that like combine like terms, or you could call that arithmetic, or you could call that definition of addition. But the key there is that you actually had two things that had an x in it. So you're not really adding numbers yet. So I am going to pull out the x, and I'm going to most clearly say I factored out the x here. That's really algebraically what I'm doing. And that was the distributive property of equality. Now notice, my version has proof, and even the other geometry teachers or the book, our proofs won't match. And that's because we're different people with different creative energies and ways of thinking about problems. And that's the reason the world's beautiful. Could you imagine if everybody was the exact same as you? There'd be no good food, no good music, no good art. Everything would just be, yeah, I expected that. That's what I would have done. What a boring place. Anyways, okay. So that was the distributive property 4. Now it really is just arithmetic. What does that add up to? Okay, so that was 4. Then let's do 5. So you could multiply both sides of the 2. I'm just going to go ahead and divide by 9/2 on both sides. Right? And so to be clear, because that's kind of a lot going on, I'm going to say x equals 18 divided by 9/2. And what let me do that? That was the division property of equality. And then lastly, Then we're just doing arithmetic, like what's that equal to? So x equals, so you flip it over, so that's 18 times 2/9, so 18 over 1. So I could cancel the 9 and the 9 and the 18, and that's a 2 and a 1, so 2 times 2 over 1 times 1. So that's x equals 4. And what let us do that? That was just some arithmetic, just figuring out what those numbers came to, or simplify, or definition of division, or something like that. Okay, so now let's complete some proofs. So the book actually started these for us. Let's go ahead and finish them, okay? So what goes first? A here, it says the reason is given. That's a dead giveaway. What was given to us? This was given. So this is 5 minus 2/3 x equals 1. Okay, then the next step shows they multiplied both sides, right? This side and this side, they multiplied by 3. That's the multiplicative property of equality. Okay, the next one, they just multiplied that in. So on the left, though, what let them do that? Multiply the 3 times both. That was the distributive property of equality. Although they also, on this side, I don't like that they did two separate things. On this side, they really did kind of also a little arithmetic, you know. Now, we won't put that in there. That's not the best answer. Really, they did use the distributive property more, but they kind of did two things at once there. That's okay, right? And the next one, they used the subtraction property of equality. So what could you subtract from both sides? I mean, there'd be no point in subtracting. I mean, if you subtracted 2x, you'd have negative 4x. But if you subtracted a negative 2x or added 2x, right? So then why would we do that? That's silly. Really, they subtracted the 15 from both sides. And what do you get left with? You get what, not 2x, but you get left with that negative. That negative sign's in front of the 2. It's attached to 2. So you're left with negative 2x equals 3 minus 15, which is negative 12. Okay, so that was a subtraction prop. And then last one, we just divided, right? They divided by negative 2 on both sides. And they got x equals 6, and so that was the division property of equality. Okay, let's do that. So prove that that leads to that. Okay, so again, we would write the given is this statement here. I'm just saving on some room. We want to do the prove, and it would be this is what we're trying to prove. And so step 1, we would write out the given, 25 equals negative 7, y minus 3, plus 5y. And then over here, we would say, well, that's the given. Okay, step 2, I'm going to use green. What am I going to do here, okay? I think I would distribute. I think I would do that first. So let's then write 25 equals negative 7y. And then that's a negative 7 times negative 3, so plus 21, plus 5y. And so that would be the distributive property of equality. So notice I'm just doing lots of examples, you guys. I really, for somebody who's stuck, I want them to have somewhere to look for practice. You can stop the video if you understand this already. Okay, so 3. What I'm going to do is I'm just going to combine these two. So 25 equals, this is now negative 2y plus 21. So that was just some arithmetic, right? Or combining like terms. Right, and then step 4, really the arithmetic's a better answer there. Let's see, then for this one, I'm going to go ahead and I'm going to subtract the 21 from both sides. And so we get 4 equals negative 2y. And so that is subtraction. And then the last one, we're just going to divide both sides by a negative 2. And so we're left with negative 2 equals y, and that's the division property of equality. It's always good to go back and check if we got the right answer. They wanted us to get negative 2. We did get negative 2, okay? So we don't have that many left. Oh, we have 100 left. So again, you can stop if you understand this. So here's single statements, and what let us get there. So if two angles have the same measure, and two other angles have the same measure, what lets us say, since A is equal to B and C is equal to B, that A and C are equal. So this is, again, we can absolutely say this is substitution, right? That's 100% valid. I would just always use substitution when we're talking about algebra. But more specifically, this is that specific case. That's the transitive property of equality. Either one 100% valid, okay? The next one, if hj plus 5 is equal to 20, well, then how do we know hj is equal to 10? Well, we subtracted 5 from both sides. So here's the subtract prop equality. Okay, if xy plus 20 equals y, xy, oh, so look, we have the same thing equals this, the same thing equals this, then how do we know that yw equals dt? This is the same as up there. So you could call it more generally substitution. You can say since yw is equal to this, I can just replace this with yw. Or you could say since they're both equal to xy plus 20, they're equal to each other by transitive property. So either one's valid. Okay, the next one, if measure of angle 1 plus 2 is 90 and 2 equals 3, then I can just replace the 2 here in this problem with a 3, because 2 and 3 are the same. So now the equation is 1 plus 3 is 90. So that one is only substitution. That's definitely not transitive. I just swapped one piece out in the middle of an equation. So that's the substitution property of equality. The next one says if half of AB equals, there they just multiplied both sides by 2. So that's definitely the multiplication property of equality. And the last one, what lets us say AB is equal to AB? So again, this is that property that we're not going to use a lot for algebra, but 100% we're going to use it later on in this course with congruence. That's the reflexive, okay? So reflexive property of equality, which says any number is equal to itself. 7 is equal to 7. That's the reflexive property. Okay, so let's complete these proofs, okay? So we start with the given, always. Okay, what lets us do multiplication property? I'm guessing they got rid of the 2 there on both sides. So they had, they just wrote it, okay? And then the next step, they actually did it. So I'll do, man, how did they do that? Okay, well, let's just write it. 2 times 3x plus 5 over 2 equals 7 times 2. I'm guessing the next step, the way they got there, again, it's kind of arithmetic, especially on the right. But on the left, you would have to use the distributive property of equality to distribute it into the terms there. So I'm guessing that's what they wanted, but you could have also just said arithmetic or simplify there. Any of those would be acceptable for me on a test. All right, and then how did they get from that step to the next? Well, it looks to me like they subtracted 5 from both sides. So that would be the subtraction property of equality. And the last one, they used division property of equality. So they divided by 3 on both sides. So they got x equals 3. We just double check. That's where we want to prove. So the last statement in every proof should always be the thing to be proven. Okay. Down here, look at this. I could just start, right? Given is always where we start. So 2x minus 7 equals 1/3 x minus 2. And the prove is always where we end. So I'm just going to go ahead and fill those in. I don't even need to know anything about the problem. I know the given is the start and the thing to prove is the end. Okay, so multiplicative property. Yeah, I'm guessing this is very similar to the last one. I'm guessing they wanted to get rid of this 1/3. So I'm guessing they multiply both sides by 3. Okay, well, that's the next step. Why am I writing on the first one? What a goof I am. Okay, equals 3 times 1/3 x minus 2. I'm going to go ahead and erase those scribbles I made on the last one. Choop, choop. Oh, and I erased some pieces of it. Okay, and then the next one where they actually send it in, that's the distributive property of equality combined with some arithmetic or simplification. Okay, just double checking. That's 1x minus 6, yeah, and that's 6x minus 21. So that is where we ended up. Good, okay. And then it says subtraction property of equality. So they could have subtracted -6. I mean, right? Like to get rid of it, or subtracted -12, but that would really be the additive property of equality. So I'm guessing the thing they subtracted here is the x, right? To get the 5x minus 21 equals, now there's no x's on this side, -6. Again, that negative stays with the 6, right? Just remembering your algebra. And then after that, they went just to 5x. So I'm guessing they added the 21 to both sides. So that would be the additive property of equality, and then they divided by 5 on both sides and check. They got to where we wanted to be. All right, let's do one last proof together, and this is where we'll end. So write a 2-column proof. So again, we start with the given. That's this right here is the given. And then we need to prove that A is equal to 1. Okay, and there's no diagram that goes with this. So we set up our 2-column proof of statements and reasons. Now, statement 1 is always the given. 4 minus 1/2 A equals 7/2 minus A. 1 given. Okay, so now where do we go with this, right? It's an art form. So, yeah, let's do what they did up there. I really let's just get rid of all those fractions. And so I'm going to multiply both sides by 2. Okay, so 4 minus 1/2 A equals 2 times 7/2 minus A. That was the multiplicative property of equality. Okay, and then step 3, I'm going to go ahead and distribute that in. Now, really, you could distribute and then simplify in 2 separate steps. I'll just do it in one. So distributing that in, I get 8 minus A, right? 2 times 1/2. And then equals, this is 7 minus 2A. So that's the distributive property of equality. All right, step 4, what can we do here? Well, we're just trying to get all the variables to one side and all the numbers to the other. So I'm going to go ahead and move the A's to this side, so we get a positive A as a result. So we now get 8 plus an A equals 7, because these are all gone now. So that was the additive prop equality. And then 5, we're going to do the same thing with the numbers. So let's get rid of that 8 over there. Okay. And then, oh my gosh, we don't even need a last step. So A is equal to -1. We don't even need that last division property of equality. That's almost always there in algebra. So this one was just the subtraction property. And again, I'm not doing sub because that could be substitution. So that's a subtraction property of equality. Boom, there we go. What an amazing time, right? So that's the idea of writing a proof using something you already know. In the next videos, we'll start using geometry and start writing geometric proofs. All right, hope you enjoyed it. Good luck, you guys.